So the topic is what? Calculus. So we'll start from, as usual, I'll give you some questions. You put that question down, as usual, before I will now enter into what we are meant to do today. Are we good? Are we good? Are we good?
Yes.
Yes, we are good. I know we are good. All right, put down this question. Number one. No, I will write on the board. I will not dictate. Okay, I should dictate?
Yes.
Okay. It's okay. It's okay. All right. Evaluate the limit. Evaluate the limits. Evaluate the limit as x. Evaluate the limit as x. As x approaches 2. Evaluate the limit as x approaches 2 of the function below. Evaluate the limit as x approaches 2. After 2, put comma. 2. Please use the figure, not letter. Not as x approaches 2, comma, of the function below. The function is x squared minus 4 over x minus 2. That's the function. Evaluate the limit as x approaches 2, comma, of the function below. Then the function is what? X squared minus 4 over x minus 2. Question number 2. Question number 2. Question number 2. Find the limits. Find the limits as x. Find limits as x approaches 0. Find the limit as x approaches 0, comma, of the function below. The function is sine x over x. Sine x over x. Sine x over x. Number 3. Number 3. Number 3. Differentiate the function. Differentiate the function. Let me now start adding ingredients small, so that you understand where we are going to now. We are climbing now, small. Let me speak in our language now. Differentiate the function equal to 3x squared plus 2x minus 5. Okay. I'm gradually coming up now. Okay? I said differentiate the function. That's the function. Function of s. Look at it here. With respect to x. With respect to WRT means with respect to what? X. So the question was what to differentiate that with respect to what? X. Is that clear? Good. Number 4. Number 4. Differentiate the function. Differentiate the function 2 sine x plus 3 cos x with respect to x. With respect to x. With respect to x. With respect to x. All right, so now let us now go to calculus now. Let us go to calculus. So let's go to calculus. Definition. Definition of calculus. Are we together? Are you sure we are together? All right. Let's look at the definition of calculus. Who can define calculus for us? Nobody. Nobody. Don't worry. Don't worry. By the time we are done with this class, you know what calculus means. All right. Put down. Calculus is a branch of mathematics. Calculus is a branch of mathematics that deals with the study of continuous change. It's a branch of mathematics that deals with the study of continuous change. It's a branch of mathematics that deals with the study of what? Continuous change. Calculus has numerous applications. Continue. It has numerous applications. It has, continue. It has numerous, you can use calculus, anyone is okay. That it is a pronoun for what? Calculus. True of us. It has numerous applications in the fields of physics, engineering, economics, and computer science. In the field of physics, engineering, are we together? Economics and what? Computer what? Science. Continue. Sorry, I like giving theoretical background in anything I'm teaching so that you have understanding of it well. So whenever they wake you up, you have something to say about it. Okay? Good. Now let's continue. Just a short theoretical background before we now go into calculation. Okay? Good. Continue. Calculus is a mathematical tool. It's a mathematical tool used to study functions and their properties. Used to study functions and their what? Properties. Used to study what? Functions and their what? Properties. Are we together? So that's why by the time we enter into calculus, you hear function. You get tired of hearing what? Function. Even the questions I gave you are all about what? Function. True of us? Good. Functions and their what? Property. Full stop. Continue. It helps us to understand. It helps us to understand how functions change. It helps us to understand how functions change as their input changes. It helps us to understand how functions change as their input changes. Once you have an input here, now look up. Once there's an input here, bam, this function does what? True of us, it change. Once you impute, there will be a change, okay? So that's what calculus is all about. It's all about what? Changes, okay? Continuous what? Changes. Let's continue. All right. Where did I stop? Sorry. As a function, though, as a what? As a input what? Change. Okay. Continue. It provides a framework It provides a framework. It provides a framework for modeling. It provides a framework for modeling. And analyzing real-world phenomena. For modeling and analyzing real-world phenomena. Yes, in real hyphen world. Real world what? It's not phenomena. Phenomena. Plural of what? Phenomenon. Thank you. It's not phenomena. Now, let's look at branches of calculus. Branches of calculus. There are two main branches of calculus. They are differential calculus and integral calculus. Differential, the one you call differentiation. Are we together? The one you call what? Differentiation. Differential calculus and integral. Integral calculus is the one you call what? Integration. Differential calculus and integral calculus. Differential calculus and integral calculus. So let's look at differential calculus. What is differential calculus? Let's just have a kind of overview before we now pick them one after the other and dismantle them. All right. Differential calculus. I write under differential calculus. Differential calculus deals with the study of rates. Differential calculus deals with the study of rates of change. It deals with the study of rates of change. and slopes of curves. Rates of change and slopes of what? Curves. Rates of change and slopes of what? Curves. Rates of change and slopes of what? Curves. The second one, look at integral calculus. Integral calculus. Integral calculus deals with the study of accumulation of quantities. Integral calculus deals with the study of what? Accumulation of quantities. Study of accumulation of quantities. In fact, in a nutshell, when you are integrating, you are increasing. Hope you know. Are you aware? When you are integrating, you are doing what? Increasing. But when you are differentiating, you are doing what? Breaking down. True of us, in a layman's understanding, when you are integrating, it's more of what? Building up, accumulating. Okay. But when you are differentiating, it's more of what? Breaking what? Down. I'm not communicating. Just with from a layman's what? Explanation. Are we together? But you know that if you go into that, it's more than that. Just a layman's understanding. Now, so they are that means they are kind of opposite. True of us. Are they opposite in a way? Are they opposite in a way? So by the time we start, we get into the two of them properly. Then you tell me whether they are opposite or not. Don't worry. Let's continue. All right. Continue under integral calculus. After full stop, continue. It helps us to find. It helps us find areas under curves, comma, volume of solids and other quantities. Area under curves, volume of what? Solids and other what? Quantity. There are some questions you will see in volume of solids and other quantities. There are some questions you will see. There are questions you will see in mathematics, JAM, or even Excel. You will be given a particular equation, and you told to find a particular formula, and you'll be asked to find area or volume of something. You don't told that you should do what? Integrate it and get the answer. Even in physics, there's a question you will given in physics, JAM. Even Excel, questions about velocities, acceleration. You will need to differentiate it. That particular equation or formula for you to get what? Velocity. Who has encountered such a first question? Nobody. Even me that is not writing down. He's studying past paper. You that write it in 2 months' time. He's not studying a past paper. But then what are you doing? It's a red flag. It's common in past question. Sometimes you may see something like this. 2t square. They may say that maybe that s is equal to 2t square plus 4t or whatever. They will ask you to find the what? The velocity. They may ask you to find the velocity. If you have, I'm just giving, just not that it will be like this. Let's assume you have an equation like this. I ask to find the velocity. This one is, you don't have to be told that this one is what? Displacement, right? Then you may be, you don't need to be told that you need to do what? Integrate this. If you integrate this, you find the what? You find what? Velocity. You accumulate, you are building. You find the what? Velocity. Sometimes you may be given acceleration. This may be acceleration. You differentiate it with respect to t to find your what? Velocity. Don't worry, you get there. By the time you get to applications, you appreciate that. Is that clear? Yes. There are many questions there in your past questions. Don't worry, let's continue. So those that think that they are not doing mathematics, you run away from mathematics. Don't worry. You sit in physics, you won't know what to do. You become what? Confused. So even if you're not doing mathematics, you're not writing mathematics, so far you are here, you will not run away from what? Mathematics. Listen, am I committing? There are some principles you will even use to even solve that your physics question. Even those in economics, those doing arts, commercial, economics, and JAM, there are questions in economics that you use differentiation to solve. It shock you. All right, let's continue. All right, so now let's look at the key concepts in calculus. Key concepts in calculus. We are done with the branches. There are two main branches. We look at key concepts in calculus. You will see some elements of the branches there. Let it not confuse you. We are looking at them as concepts now. Key concepts in calculus. Key concepts in calculus. There are three key concepts in calculus. Right? There are three key concepts in what? Calculus. Three key concepts in calculus. They are limits. Limits. Limit. The first one is limits. Limits, comma. Derivatives. Limits, comma. Derivatives, comma. And integrals. And what? Integrals. These are three key concepts in what? Calculus. Limits, derivatives, and what? Integrals. Limits, derivatives, and what? Integrals. So let's look at limits. Let's look at limits. Let's look at what? Are we together? Let's look at limits. Okay, you're right. Right. Limits focus on how functions. Of course, when we say functions now, you are talking about this, okay? Hope you know that this is the same as saying y is equal to, that's the normal y is equal to 3s here. So don't be afraid. Don't be scared because of this f function of y is a function of what? Is it y that is a function of s or s is a function of y here? Which one? F of x mean what? Is it y and y is okay, which of them is dependent and independent now? Start from there. Is it y that is dependent or x? Y is dependent on what? X. So which one now is the function of x? Is it y that is dependent on x or s is function of? Is it s that is dependent on y or y is function of s? Function of s. Because once s change, y will do what? Change. And that's why you plot your graph. You have different values of what? X. At each value of s, y will change. True of us. Because y is depending on what? So y will now function based on whatever s presents. Am I communicating? Am I communicating? I'm breaking down mathematics. Mathematics, I'm breaking it down so that you know that it's not difficult. All you need to do is just to understand the principle behind it. Am I communicating? Understand the words, the principle, and you are good to go. Now, let's look. As I said that limits. What did I say about limit? What was the first thing I said?
Focus on how functions.
Focuses on how functions behave. how functions behave. How functions behave as their input approaches a certain value. So this one talks about how a particular function behaves as their input approaches a particular what, a certain what value. Are we together? Are we together? So you must have seen some questions in JAM. You see something like this. You see something like this. Maybe have you ever seen something like this? Yes. Yes. This talks about the limit, right? What is trying to let you know? You want to test the behavior. The function is this is the function. The function is this: 2x squared minus what? 3. So we want to test how this function behaves as s approaches what? 0. What it means is that you substitute x for what? 0 for what? X here, right? So whatever value give you the limits, right? Are we together? It's a simple thing. It's not something. Forget all those big grammar we are blowing here. Are we together? Are we together? So let's continue. So that's what limit talks about. So it looks at how that a function behaves when its value tends towards a particular what value. So sorry, my dear. So you can put down this, okay? The limit of f of x, that is this. Just write the limit of this, okay? Write this. The limit of this as s approaches a is L. The limit of fx, as you see on the board, as x approaches a is L. I made a statement now. L, capital L. The limit of fx as x approaches a is L. Who can write this? Who can write what represents what I just said now on the board for me? Okay. I said that limit of function x, right? As x approaches a is L. Who can represent it on the board for me? Sharp. Who can do it? Sharp. No time to waste. Who can do it for us? Who can represent this I just said now on the board? Who? Oh yeah, John Bite. Where is your confidence? Where is your confidence? Oh yeah, come and do it. The man is saying to do it. He's pushing you to do it. Come. Fast. Even you, he's pushing you to do it since you refuse. Come. Fast. No time to wait. Fast. Stop making noise over there. Oh yeah. I said that thing you put down now, that the limit of this as x approaches a is L. Oh yeah. Okay, thank you. You got it. Thank you. There, come. But there's something you are missing. Come. There should be limits here. You should write here. I do it. Then this will be under it. Okay. Yeah. You are here under it. Correct. You got it. got it. Clap for him. He got it. So please, in case you see this in jam question, it's there in jam questions. It's always there. It's there. Please don't be afraid. It's nothing. By the time we start solving questions, you understand? Okay. Now, let's continue. This is for the first concept. Let's look at the second concept. The second concept, we have mentioned it before, but let's just say it again. The second concept is derivatives. Derivatives, or some call it derivatives. Derivatives. Are we together? All right. This measures the rate of change of a function. This measures the rate of change of a function with respect to its input. This measures the rate of change of a function with respect to its what? Input. We have agreed before now that as the input is changing, a function is what? Changing, right? But derivative is trying to measure the rate of that change. Are we there? The rate of that change the function undergoes when an input is what? Put in place. Are we together? We want to measure the rate of that change, and that's what we see in differentiation. True of us, rate of change. We want to actually determine the rate of that change. We know that there is a change. There must be a change. At what rate does the change take place? That's what derivatives want to let us do what? No. Then the last concept is integrals. We have defined it before, but we want to now fine tune it as a concept. Integrals measure the accumulation of a quantity. Integrals measure the accumulation of a quantity over a defined interval. Here now, it's not just talking about accumulation. How is it accumulated over a given interval? Over a given what? Interval. We are talking about what? Integration. That's why sometimes you will see an integration question comes like this. You have two intervals, right? Upper one and what? True or false? You want to determine at a particular what? Interval. Are we together? You check it at this interval and at this and subtract. And now determine the accumulation over a defined what? Interval. Now, let's round it up by looking at applications of calculus. Applications of what? Calculus. Applications of calculus. Number one, physics and engineering. Physics and engineering. Physics and what? Engineering. Physics and what? Engineering. Sorry. Physics and what? Engineering. Okay. Calculus is used to model. Calculus is used to model motion of objects. Used to model motion of what? Objects. Comma. Including the acceleration. Including model the motion of objects. Motion of objects, comma, including the acceleration. Including the acceleration and velocity of particles. Acceleration and velocity of what? Particles. And the curvature of space-time. and the curvature of space hyphen time. That's why remember I told you how you can differentiate acceleration to get what? How you can differentiate acceleration to get what? Velocity. Remember that, right? So this is also the application in physics. Now, let's look at its application in economics. There are many applications. We just limit ourselves to this because so we don't talk too much on theory, SS. I want to run it off so we can move straight towards calculation, okay? Let's look at economics. Calculus is used to model economic systems. Calculus is used to model economic systems, including behavior of markets, and impact of policy changes, including behavior of markets and impact of policy changes. Is there anybody offering that will write economics in JAM here? Economics in JAM here? Have you ever seen past cases whereby you see demand and supply? You just see it. You guys see calculus there. You don't see function only multiple function. Okay, yes, that one is in the price determination, right? Yes. Let's continue. Then computer science. In computer science, calculus is used in computer graphics, machine learning, computer graphics, machine learning, computer graphics, machine learning, and algorithm design. In this year social media, you see the algorithm. Some things will just be coming to your watch, FYP. All those things have been programmed. Am I communicating? There are some social media. You are there doing social media. There are some countries that their own have been programmed that what their own children are seeing in their social media are tech posts. There are some, what they see is where they are twerking and they are used to wasting, and they are used to be what? Wasting. That's the world we are in. So that's the power of what? Algorithm. You don't know? Okay, you are not aware. I'm telling you now. You're aware, right? Okay, they are aware. And because that's what you enjoy, so they give it to you more. The idea is to make more money, true of us, because there are companies around here that pay for advert, true of us. So if they don't give you what you want, there will be no views, and this advert will not be seen. It's not true. So they give you what you want. If what you want is prayer, they load you with prayers. If what you want is tech research, they give you research. If what you want is where you are doing nonsense naked, they give it to you, and you're enjoying it. Their aim is to do what? Make money. Because big companies pay for adverts. So understand the algorithm. Let's continue. So you can leave a paragraph. Let's conclude this so we can now enter the main thing. I will use the few minutes remaining to enter the main thing. So continue. Paragraph. Just paragraph. Let's conclude this. Calculus is a powerful tool. Calculus is a powerful tool for understanding and analyzing complex. I think I've said it before now. Complex phenomena. Yes, it has numerous applications in various fields. It has numerous applications in various fields. I said that is a powerful tool for understanding and analyzing complex phenomena. Full stop. It has numerous applications in various fields, and is a fundamental subject. For anyone interested. Is a fundamental subject. It has numerous applications in various fields. Look at recap. I said that calculus is a powerful tool for understanding and analyzing complex phenomena. I've said this before. Full stop. It has numerous applications in various fields, and it is a fundamental subject for anyone interested in pursuing a career in science, technology, engineering, and mathematics. Is a fundamental subject for anyone interested in pursuing a career in science, technology, engineering, and what? Mathematics. Sorry. So let us now go into differentiation. Let's go into differentiation. All right, differentiation. These days, you guys are lucky. When we are in secondary school, what we had that time was just general mathematics. There was no atom of this topic was not in our curriculum then. You know that my personal quest to know this thing, we had no teacher for further mathematics. Just my personal quest to know all this, to know mathematics more than just ordinary mathematics. I had to go and start studying further maths by myself. No teacher to teach us in school. I bought mathematics by myself and started studying it. And it helped me in mathematics. In my school, they were like, why do you want to write for mathematics? No teacher. Are you sure they will bring question for you? I say I don't care. I'll put it in WAEC. I put it. 200 people saw the zeal and joined me. Became 3. I was surprised that during our WAEC left their office with 3 question papers and came to my school. I was shocked. I was, wow, who am I? You know, it helped me a lot. So, as God may have it, as God may have it, I was able to scale through. I got this C6. Those two guys failed it, but it's okay. But at least they worked hard for it. So the point I'm trying to make is this: nobody can stop you. It's only you that can do what? Stop yourself. It's only you that can do what? Stop yourself. But now, recently, if you open mathematics textbooks, general mathematics, you see calculus here. Two of us, you know what that wasn't there. It wasn't there. If you just revised it and they added it, it wasn't there. You must go and study further mathematics for you to know it. I went to the set of buying engineering mathematics in SS2. Who has seen engineering mathematics by K. Stroud? Who knows that textbook? I bought it in my secondary school just to know further mathematics. So that's why when I said after everything I did, I couldn't get mathematics A1. That's why you see a human being that doesn't know the meaning of S square, what S square is supposed to for, what it is. Having A1 in mathematics, I cry when I see such people. So if you are among those who please try learning mathematics today, because that's the implication to me. That once one year I was teaching mathematics, I said S square is equal to 4. I was just casually now, okay. You know, if you are teaching maths, you ask question, the person, if you are solving, the person should do what? Response, you know. Okay, we got the point. S square is equal to 4, so S is now equal to silence everywhere. I turn. S square is 4. S is now equal to silence again. I say wait too. S square equal to 4. S is equal to what? The next response was, sir, I am not very good at mathematics. And the person was preparing for nursing school. You know, they write maths now. I said, wow. Then how did you pass mathematics in your WAEC? Because I am always interested in mathematics. Because of the exploits we did in mathematics that time. We're the first set that started cowbell mathematics competition in Nigeria. So I was like, as the first people that wrote it, I was like, I became so much interested in mathematics. I asked her, please tell me, how did you make mathematics? What did you study mathematics? She said, I scored A1. Hey, I was shocked. I do became angry because I know that I couldn't get A1. I was very angry. How can someone that could not solve this got A1? And me, after me, I couldn't get there. I said, now tell me, what happened? She confessed that she wasn't the one that wrote it. Please don't do like that, please, I beg you, man. Don't be what? It's not good. Are you aware that you may go for a job interview? Those interviewing you may see you are resulting. You may even be after your graduation. Be careful of what you parade around with. Because sometimes those people that would interview you will lack questions to ask you. I have been in panels. Sometimes it may be that morning that they formulate questions they will ask you. Sometimes it may be as they see you, question will come out. Someone that knows mathematics may see as A1 mathematics. Wow. Maybe like ask you one simple question in mathematics. If you cannot answer it, you have failed at that interview. Do you know why I said that interview may not be for mathematics? No, you are not there to do calculation. Do you know why I said that you may fail at that interview? It may even be to be a news broadcaster. It may even be to do something that has not been a business with mathematics. You may fail at that. Do you know why? When the person sees A1 in a result, and you cannot answer simple question in mathematics, do you know what the person will assume? This person has no integrity. That this he came from example was malpractice. So this person has no integrity. We cannot trust this human being with this position, and that's final. So be careful. So be careful about what you are doing. Lay what good foundation for yourself. That's what I mean. I will tell that. Now let us now go. I don't just teach. I teach live because tomorrow I don't know where I'll meet you. tomorrow we are building to go and do what export out there tomorrow. Okay? So it's not just about what there are some things that you cannot see in any textbook, and you cannot see it on the whiteboard. Maybe through your interaction with your lecturer, sharing experiences with you. Am I committing? That's why you don't miss your lectures. Even when you enter higher institution, don't miss your lectures. Because there are a lot of experiences the lecturer will be sharing with you. You cannot see in any textbook. Alright, so now let's look at differentiation. So differentiation, put down. Differentiation is a fundamental concept. Differentiation is a fundamental concept in calculus. Differentiation is a fundamental concept in calculus that deals with the study. I've said it before now, but I'm just saying it officially again. That deals with the study of rates of change, and slopes of curves. That deals with the study of what? Rates of change and slope of what? Slopes of what? Curves. Rates of change of seafood. People are enjoying here. And we're there suffering. All right. Rates of change and what? Slopes of what? Curves. Are we together? Yes. By the time we go into that, are you okay? Rates of change and slopes of curve. Good. Now, what we are going to, I want to give an outline of what we are going to do under this topic. All right, have a list of what we are going to cover under this topic now. Number one. So under this topic, we are going to cover the following. Number one, limits of a function. Limits of a function. Number one is limit of a what? Function. Then number two, differentiation of explicit. Don't mind me. X what? Explicit what? Differentiation of what? Explicit algebraic and trigonometrical functions. Differentiation of explicit algebra from algebra, right? And what? Trigonometrical what? Functions. Explicit algebraic and trigonometrical what? Function. In a nutshell, I'm saying that we just look at limits of a function, then we look at differentiation of algebraic function, right? At the same time, trigonometric function like sine x. If you differentiate sine x, what will it give you? If you differentiate cos x, what will it give you? If you differentiate tan x, what will it give you? And sometimes you also see another function inside that what? Am I concreting? These are things you are going to what? Look at. Are we together? Now, let's look at limit of a function. Let's start with what? Limit of a function. Let us now go to limit of a what? Function. limit of a function. Hey, you lovers, wait a bit, just wait. Lovers, wait for some time, please. Let's finish. You can now, So let's look at limit of a what? Function. Alright. Limit of a function, the limit, they start with the limit of a function. The limit of a function is a fundamental concept in what? Calculus. The limit, the limit. Hope you know that. This one is pronounced what? The limit, right? This one is pronounced what? The limit. I hope you know. Are you aware? The limit of a function is a fundamental concept in calculus. It's a fundamental concept in what? Calculus that describes. It's a fundamental concept in calculus that describes the behavior of a function. That describes the behavior of a function as the input approaches a specific value. As the input approaches a specific value. As the input approaches a specific value. Paragraph. Next paragraph, please. The limit of a function f enclose x in bracket after it, as usual. Write the limit of a function now. You now write this, okay? The limit of a function. Then write f brackets x in brackets as x. The limit of a function as x approaches as s approaches a. As x approaches a. The limit of a function fx as x approaches a is denoted by this. By someone has answered it here. Are we together before? Are we together? Yes. So just put it as a note so that when we are going through it, it will sink more. Okay. The limit of a function as x approaches a, is denoted like this. Are we together? And represents, continue. And represent the value of fx. And represent the value that's not of, please. That, please, not of. Cancel that off. And represent the value that's. Cancel off, please. That fx. I'm trying to point out what it represents. It represents the value that fs approaches, because it approaches a particular value that fs approaches. It represents a value that fs, the function, approaches as x gets arbitrarily close to what? A. And it represents the value that this function approaches as x gets arbitrarily closer towards a. So as this s gets closer to okay, arbitrary is the issue. Don't worry. Arbi is from arbitrary. Are we together? But what I called is arbitrarily. So tell me which one is, what parts of speech are they now? Oh yeah, use of English. Arbitrarily. Oh yeah, use of English. This one is what? This one is what? This one become. It's not everything that has ly is adverb. So this one is not this one. Verb. Is it verb? Is it noun? Is it adjective? Arbitrarily value is qualifying a value. So what is this? It qualifies the noun value. So what it is? Arbitrary what? Value. So it's what? So this one becomes what? Adverb, right? Adverb, right? Alright, so see the one I pronounce I called, please, not this one. So I say that it represents the value of the function fx, right? As s gets arbitrarily close to a. So what it means is that we are going to equate this whole thing now to a value. This function will become as x approaches, get close to what? A. Am I concreting? So that's why the limit becomes L. That one I called before now. If this limit of this is L, what it means is that the value of this function is L, right? As the value of x approaches A. That's the meaning. Are we together? You say what? Okay. I thought you, but you understood what I said. Are you sure? Don't do a big deal. Did you understand it? Good. Now, put down this question. Put down this question, please. No, that one is the one you do it. Just do it on your own. I'm giving you the one we are going to. Hey, someone's daughter is already afraid. Without wasting time, don't be afraid. You can do it. Believe in yourself. You have what it takes. Okay. All right. Put on this question. Let me write it on the board. After this, we'll continue next week. After solving this question, we'll continue what? Next week. Are we together? All right. So now, look at this question. Find the limits. Hello, the question says find the limits of this x tending towards 2. The function is 3x plus 4. So what the want us to find out the value of this as x tends towards what? 2. So what's the answer? Sharp. What's the answer?
10. 10.
Is it 10?
Yes.
Are you sure? Is it 10?
Yes.
What of this one? That one is what? Is easy, right? We will start from the easy to the what? Difficult. We'll start from the known to the what? Unknown. We'll start from the visible to the what? Invisible. Start from the mortal to the what? Immortal. Gradually we are moving. By the time we enter the difficult one, you won't even know self. Two of us, you won't even know, because you'll be solving it and the thing will sweet you. By the time you look back and say, when did I learn all these things? Because you take it step by step. All right, now let's. Are we together? Are we together? Are you sure? You are not sure. Okay. What of this one? What of this question? Maybe I will just take style, solve one I gave you, sir. This one, uncle. Is it zero? Yes. Sharp boys and girls, sharp ladies and gentlemen. That's good. I'll be like when I grow up. What of this one? What of this one? What of this one? Look up, please. Find the limit of this one. Limit as x approaches 3. The function is 2x squared minus 5. The function is 2x squared minus 5. Is it 13? Yes. Are you sure? Yes. 9 times 2, 18 minus 5, 13. And this is how we scattering down question without even lifting your pen. Say amen. Amen. But be careful so you don't make mistake, okay? Alright, so in our next class we will now enter what? You know, we talked about what? Limit. In the next class we'll go into what? Derivatives, okay? The first thing we'll do, I'll give you the rules of differentiation first. They should be up to 8 or so. Up to 8 of them. Rules of differentiation. I'll give you all the rules. Huh? So I'll give you the rules, then and tell you when to use each of them. Are we together? So that's what we enter in our next class. Then after, if we comprehend it very fast, we move over to integration. Are we together? Because I'm following your syllables. I'm following your what? Syllables. All right. Any question? Huh?
The occupants rule.
Occupants rule of what?
I don't get it. The occupants rule.
Is it under the differentiation? I'll look into that. Let me. I will. All right. Write it and give me. Let me see. Write it and give me. All right. Thank you very much. God bless you. See you next week by God's grace.